This is the last video in Module 6. We're covering structured troubleshooting, a repeatable ordered process for diagnosing network connectivity problems. Structured is the operative word. Random troubleshooting wastes time, sometimes makes things worse, and usually ends with a fix that you don't fully understand and can't explain to anyone else. A structured approach eliminates variables systematically, finds the cause faster, and builds your understanding of the network with every problem you solve. When a SCADA pole fails, or an HMI loses communication with a PLC, or a historian stops receiving data from a remote site, the instinct is to try things until something works. Try rebooting the device, try a different cable, try disabling the firewall temporarily. If one of these works, great, but you don't know why it worked, which means you can't be confident the fix is permanent and you can't explain the root cause to the engineer who needs to update the documentation or the maintenance plan. A structured process solves this by starting at the physical layer and working up, confirming each layer before moving to the next. If you confirm that the physical connection is good, the IP addressing is correct, the routing is correct, the firewall isn't blocking the traffic, and the service is running on the destination, and communication still fails, you've isolated the problem to the application configuration, and you know that because you've confirmed everything else. The framework maps directly to the TCP/IP model from Module 3. Work from the network access layer or the physical. Let's work from the physical layer up through the internet and transport layers, and then finally to the application layer. Most communication failures are resolved somewhere in these first 4 steps. Step 1, physical connectivity. Look at the cable. Is it seated firmly on both ends? Is the port LED on the switch lit? A port LED that's off or amber instead of green indicates a physical link problem. The devices aren't even establishing an electrical connection. Check the cable at both ends and try a known good cable if available. Link status, step 2. Run the command show IP interface brief, the same command from Video 5's host discovery on the connected switch or router. Here you're reading the 2 status fields. Up means the physical layer and the link layer are both good. Down confirms a physical problem. Administratively down means someone shut the interface down in configuration. Step 3, IP addressing. Confirm the correct IP address is assigned to each device. A PLC that was reconfigured during maintenance may have gotten a new IP address that doesn't match what the SCADA server is trying to reach. On a Windows device, ipconfig shows the IP configuration. On the network device, show IP interface brief shows assigned addresses. Step 4, validate your subnets. Confirm that the source and destination devices are either on the same subnet and can communicate directly, or they are on different subnets with a correctly configured router between them. A source device at 10.10.1.5/24 trying to communicate with a destination at 10.10.2.5/24 cannot communicate directly. Those are different subnets and a router is required. If there's no router in the path or the router doesn't have a route to the destination subnet, communication will fail. If the physical and addressing layers check out, move to the logical stack. These steps address routing, firewalls, name resolution, and application configuration. So step 5, check the default gateway. Confirm that the source device has a default gateway configured and that the default gateway IP is correct. Ping the default gateway IP from the source device. If the gateway doesn't respond, the source can't route any traffic off its local subnet. Check the gateway configuration on the device and verify the gateway is online. Step 6, DNS. If the application is connecting to a destination by host name rather than IP address, name resolution must work for the connection to succeed. Confirm the host name resolves to the expected IP address. If you can connect using the IP address directly but not the host name, DNS is the problem. Check DNS server configuration and that the DNS server is reachable. Step 7, check your firewalls and ACLs. Check the logs in the firewall for denied traffic, matching the specific connection that's failing. A deny log entry for the exact source IP, destination IP, and port you're troubleshooting confirms the firewall is the problem. Review the rule set for the applicable interface. If the deny rule shouldn't apply, correct the firewall configuration, but confirm first that the allow rule you intend to add is consistent with least connectivity principles. Step 8, application layer. If steps 1 through 7 all check out, physical connection, IP, routing, and firewall, the problem is in the application or service. Is the target service actually running on the destination device? Is it listening on the port you expect? On Windows, netstat -an will show all open ports and listening services. On a PLC or RTU, the vendor management interface or commissioning tool will show the service configuration. A critical habit that distinguishes effective troubleshooting from random attempts is to document your steps and findings as you go, not afterward, during. Write down each step you took and what you found. Step 1, maybe write down port LED is green, cable is seated. Step 2, I ran show IP interface brief, shows that gigabit interface 01 is up and up. Step 7, firewall log shows deny entry for certain subnet, certain port. This documentation serves several purposes. It prevents you from checking the same thing twice when you lose track of what you've already verified. It gives you a root cause record you can share with the engineer who updates the network documentation. It makes the next troubleshooting session for a similar problem faster because you have a reference. And if you need vendor support, having a documented sequence of what you've already verified saves significant time. The structured approach also applies when assessing your network from a security standpoint, working systematically from known assets to unknown assets, from documented services to actual running services, from intended firewall rules to verified firewall behavior. The same discipline applies. Now, as you do network troubleshooting and become better at it, you will decide maybe that these steps don't work out exactly the way that you would like them. In fact, most of the time that I do network troubleshooting, I don't always jump to the physical layer. That requires me to be in front of the device at the station, and that becomes challenging sometimes. So sometimes I will start with ping that I already know the physical layer is fine. I already know the IP layer is probably working. So a ping is a very easy remote way to get started. So you don't have to follow these steps exactly, but come up with some steps that you would like to follow, or follow these until you understand how networking works, and then you can develop your own patterns for troubleshooting. This wraps up Module 6. In Module 7, we bring everything together. We'll trace a real attack path through the concepts from every module, walking through a practical defensive checklist and point you to the standards and frameworks that formalize these practices in your industry.